A warm welcome to the KONTEXT webinar on circular economy for competitiveness and resilience. I'm Sarah, and I'm here today with my colleagues Katharina Rogenhofer and Johanna Roniger, and we'll lead the webinar today. What you can expect is the first 30 minutes will be input on our circular economy studies, and then there is space for 30 minutes discussion. We have space for all your questions and input, and we are really looking forward to sharing and learning from you. The first 30 minutes will look like this, that our speaker of KONTEXT, Katharina Rogenhofer, will introduce the 3 studies and the topic at hand, and then Johanna will present the main learnings from the studies and also policy implications that will then be rounded up by the geopolitical implications by Katharina, and then we'll start the discussion. And as you know, we'll have 3 studies being presented. They have been written together with the Supply Chain Intelligence Institute Austria and the Environmental Agency Austria. And they are on the topic of modernization and resilience, and we'll dive deeper in a second. Some housekeeping first. Feel free to turn your video on. It will be the video will be shared publicly later, so keep that in mind. You can always write in the chat with feedback. If you have questions, you can put them in the F&A, the Q&A. You find the button at the top. And we will collect the questions there and answer them in the end. So you can already type the questions during the presentation. If you have any questions, you can write them in the chat also, and I'll try to answer them in the meantime. And after the webinar, you will get a follow-up with the 3 studies, a summary of the studies, and the link to the webinar. So you can also forward it to your colleagues. All right, and this I hand over to my colleague Katharina.
Thank you very much, Sarah. Welcome to our webinar. For those of you who don't know KONTEXT so well, or also me, my name is Katharina Rogenhofer. I'm the founder of KONTEXT, and we are an independent research institute dedicated to analyzing the political, economic, and social dynamics that shape climate action, or the lack thereof. We work on topics ranging from energy and electrification to circular economy and finance. Our work is evidence-based, solution-oriented, and designed to bridge the gap between science, policy, and practice. But I'm also a zoologist, and I've spent a lot of time observing animals. And if there's one thing that's really struck me, it's this: no other species produces waste. None. Not ants, not bees, not even the most complex mammals. They all live in cycles: taking, using, and returning. We humans, on the other hand, we call ourselves the rational ones, the innovative ones, the crown of creation. And yet we've built an entire economy on digging things up, using them once, and then throwing them away again. That's not rational, that's a design flaw. But circular economy is not just about using less resources and saving the planet, it's about securing our prosperity. Let me break that down to you. Every year, the EU loses billions by not recycling materials. Or, to put it positively, a massive growth opportunity for businesses that lead the transition. As for competitiveness, China already controls 70 to 80% of critical raw material markets. If we don't invest in circular technologies now, we'll depend on their prices, their supply chains, and their rules tomorrow. And as for security, the pandemic, the war in Ukraine, disruptions in the Strait of Hormuz taught us how fragile global supply chains are. Circular economy means resilience. It means we're not begging for resources when the next crisis hits. And let's be honest, it's also just common sense. Why would we throw away what we already have and can reuse? why would we create dependencies where we could have autonomy? The 3 studies that we will present today will prove that circular economy isn't just possible, it also reduces our resource use, it creates jobs, and it drives innovation. But that requires 3 things. First, stop focusing on recycling alone. We need to reduce demand through durable design, reuse, and repair initiatives. Second, we have to make circularity operable with quotas, harmonized standards, and end-of-life criteria. And third, we have to embed it everywhere, in industrial policy, trade, and climate law. And if we succeed, well, then maybe we'll finally earn the title we've been giving ourselves all along, the rational ones, the innovative ones, the crown of creation, however you like it. So with that, I'll hand over to my colleague who will present the studies in detail, and I'm looking forward to the discussion following the study presentation. Thank you very much.
Thank you, Katharina. So I'll end the spotlight and I'll share slides again. Sent. Should be loading now. Looking good. Okay. Yeah, so thank you. Welcome also from my side. I'm actually quite excited to be sharing all the work we've been doing for the past 8 months or so. It's been quite a ride, the different studies, and we've also talked about them in different settings already. We've been to Brussels 2 weeks ago where we also presented them, and now kind of coming full circle back to Austria and looking at the participants. We have really a wide range from different countries, different institutions, different positions. So very cool to be here. And let's dive in. I hope you can take away a lot and we can have a good discussion afterwards. So, as been mentioned, there were 3 studies that we did, focusing on different aspects of circular economy. For the first one, we looked at the most resource and energy intensive industries, so metals and particularly the construction sector. For the second one, we looked at the potential from exports and the recycling industry, which can have just a particular impact on competitiveness. And then for the third one, we looked at critical raw materials and how circular economy can reduce our dependencies. So kind of 3 different benefits of circular economy demonstrated through different modulations and calculations. Yes, the first one, as Sarah mentioned, is done with the Austrian Environmental Agency. There we looked at the whole economy first and the material use. Austria has actually quite ambitious goals regarding materials use. They want to bring the material footprint from around 22 tons per person per year down to 7 tons by 2050. So the amount needed per person bringing down to 1/3 of what it is now. In the EU, there isn't a target for material footprint, but there is one for the circularity rate, which is supposed to double until 2030 from 12 to 24%. So in 4 years, it should double. That's quite ambitious, particularly considering the progress we've made in the past few years, which are quite low. The material footprint in Austria has decreased only about 1 ton in recent years, and the circularity rate in the EU has increased 4 percentage points in the past 20 years. And now we need to go to double it in the next 4 years. So how can we reduce this? First, we need to think about what materials are we actually talking about? What's the bulk of it? And there is a clear picture that over half of EU's material comes from one group, the non-metallic minerals. So that's mostly materials for construction. That's sand, gravel, cement. And then we have biomass, also a big part, fossil energy materials, and metal. And so for the first study, we focus on 2 sectors, the construction sector and then the metal sector, which is of strategic importance for Austria because it brings such high emissions with it. And then we use a large macroeconomic input-output model that the Austrian Environmental Agency has. And we wanted to see what would change until 2040 if we transformed these two sectors in line with the circular economy. So for the building sector, we inputted measures such as higher renovation rates, vacancy mobilization, increased use of recycled and bio-based materials in constructions. So that would mean less cement, more wood. And for the metal sector, it was mostly higher scrap rates and then electrification with also renewable energy. So looking at the results, we could see that we looked at not only the environmental output, but also economic ones. And we could see that there are really benefits across the board. For material consumption first, the one on the left, actually I can even use the pointer. We can see that in material use, it's a decrease of 29% for housing. And also within that, we can see that there is a massive shift from non-renewable resources to renewable ones. So from limestone and dolomite for cement production, from sand and gravel for concrete to wood. And then apart from the material consumption, we see that the energy production becomes a lot cleaner. There's a large reduction of coal and gas, increase in green electricity. And that also means less imports of fossil fuels. In line with that, our emissions decrease by around 20%. That is largely attributed to the metal sector, which in Austria has a very large share of emissions. So the steel. And we also see the energy prices drop, especially in the steel sector, because electrification and renewable energy in the long run is significantly cheaper. So they were in our model at 11% lower. And also the output prices decrease in the steel sector and the building construction. And then when looking at value added and the jobs, we could see that there is a massive shift, obviously, from some industries to the others. For example, there is less new buildings, but then there is more renovation. So then it changes and the jobs change, and that needs to be done in a just way. But it is important to highlight that that does not mean that it has to be an economic downturn, but the economy is actually stable. There's even a slight increase in the labor market and in job and in GDP. So that's the main results from the first study, where we try to give this big picture and show that even if we look at these really big and kind of difficult parts to decarbonize and to make circular, they're not actually that much trade-offs. There's actually a lot to gain in different aspects. So for the second one, we wanted to look a bit more closely in what we have to gain. And there, circular economy has a lot of business models with a lot of potential. Here we focused on recycling, mostly because it's the easiest to measure, because the recycling sector is kind of one sector in itself that can be modeled, whereas other business models mostly fall into different economic sectors. So we looked into recycling capacity and also recycling machinery, where Austria has a strong base. So we also did a macroeconomic model with the Austrian Environmental Agency, where it was mostly about the extrapolation of current positive trends, that we're recycling more and the industry is growing, together with the potential market growth in the EU for recycling. Yeah, so in general, we also looked at the starting position that Austria is in, and actually different member states have different specialities. And for Austria, we have a very high technological expertise. So we have a lot of patents, specifically in plastic, but also in textile industry and others. So it's very well positioned to seize these opportunities. Also considering that we have technologically leading companies and a broad industrial base. So we looked at what if we actually leveraged these good conditions and fuel the exports with it. So as mentioned, the model had kind of two parts. One is the recycling machines. So we extrapolated the trends there. What if we export more recycling machinery? And then the other part is the domestic recycling sector. And we put these two models in one for the results. And I need to deactivate the PowerPoint. Doesn't work quite yet. This should work. Yes. Yeah, so there we see the results, which are pretty cool, actually, considering that it's most in extrapolation. Here, the exports that are modeled, and then the effects also on GDP, jobs, and investments. So we see that these two parts together bring a GDP increase in 2.2 billion and a job increase in over 20,000 jobs. And here it's important to note that these positive effects, they're not only in the waste management sector, but they unfold across the entire value chain. So the sector that benefits the most is obviously waste management, but then also mechanical engineering, the machineries, industrial suppliers, and then all kinds of trade and service-related industries. So circular economy, we can see even if it's just about recycling, it doesn't act as an isolated niche sector, but it's a driver of the economy as a whole. And then what we did as well in this study is not only take this very big macroeconomic view, but actually look at companies and how they are already leveraging circular economy to fuel their business. So we looked at 3 sectors in particular: plastic, metal, and building. We talked to a lot of front runners and looked what they're doing in terms of circular economy and why. And we could see that for them, it's mostly not about policy that's fueling their motivation for circular economy, but that it's business opportunities that they can kind of enclose new markets, or they can save resources that would be expensive for themselves. So for plastic, for example, we in Austria have a huge plastic industry, but still most plastic is being burned instead of recycled. And we're quite far away from reaching the target of recycling 50% of plastic. We're around 25%. And there are actually quite few EU countries that have reached this goal. Belgium is one of the few, and then countries like Austria and France are only around half. And there are actually a lot of economic push factors as well for increasing recycling, like the volatile oil prices, increasing consumer awareness, particularly with packaging, and others. And yeah, we identified, and feel free to look up the best practices in the study if you're interested. Quite a lot of pioneers, like a large AI-driven sorting machine, a closed-loop PET recycling bottle-to-bottle from the Austrian beverage industry, and then recycling machine companies that are exporting across all continents. For the metal sector, we also have in Austria quite some frontrunners that are recycling aluminium, copper, and steel. And for copper, for example, it's up to 100% recycling. Also aluminium, you can recycle it over and over again, and thereby reduce your input dependencies, reduce energy as well. For aluminium, it's 95% energy saving if you recycle it versus if you make it primary. And then in the circular building sector, there is also a lot of business models that are emerging now and that are being slowly scaled up. As the building sector makes up 3/4 of all total waste, this is really the bulk where you need to look at when reducing resource consumption. And right now, secondary raw materials are being used, but mostly in very low value applications like roads, subways, crushed concrete used under the asphalt. But in higher value recycling, like reuse of building components, that remains the exception so far. And here also we have some Austrian pioneers, like company making the rental of building equipment standard, or a waste management company that documents the waste containers digitally, making it easier to reuse and recycle, or a company starting to systemically reuse building components like windows or doors after deconstruction. So we have a lot of innovation and a lot of companies wanting to move, but the difficulty is scaling it and making it systemic. So for reuse, for example, you really need the systems in place to actually have it cataloged, to know what's there and to know where to store it and so on. So we also did a survey with the front runners asking them, what currently motivates them and what they need to scale. And they said it's mostly right now market driven, but they also need a policy to scale and to stay in stable business. Yeah, and as I said, Austria is very well positioned, but despite the strength, the potential is so far mostly untapped. And so the right measures are needed. And obviously also other EU countries could benefit from them. Then we're already coming to the third study, which was about security. And we looked into the 34 critical raw materials that are defined by the EU as particularly important and rare. And we more closely zoomed in on a subset of that, the strategic raw materials, so the ones that are really used for our strategic priorities in the EU, such as decarbonization, digitalization. So we did that together with the Supply Chain Intelligence Institute. And first we looked at where do we even need critical raw materials? What are they used for? And that's much, much wider than we thought. So this dark red one are half of all the Austrian exports, which are relying on critical raw materials. So if the supply of critical raw materials is constrained, it jeopardizes approximately half of Austria's export economy. And that's actually quite similar for most EU countries. So out of these 34 or 17 particularly important materials, we wanted to look at which are really immediately endangered and where is the dependency particularly high. So we ranked all of them by methodology from the European Commission, where there are 4 indicators, 2 on import concentration and 2 on import dependency. So import concentration means where are we importing these materials from? Is it from many countries, then it's relatively safe, or do they come from 3 or less countries? And then is one country responsible for over 50% from all our imports? And then for import dependency, the question is how substitutable are those inputs with our own production? How much can we produce ourselves? So we ranked particularly the 17 strategic raw materials, and we found that 8 of them are severely at risk, and 34 are also at risk. That means that they surpass the threshold in all 4 indicators. And even if we look at the ones that do not surpass all the indicators, many of them are still very exposed. And for example, for cobalt, the data showed us that it's relatively diversified, but then a lot of the imports are actually re-imports that again come from the Congo. So some of the data actually underestimates the actual supply risk because of the structural dependencies that are not really easy to capture. And for cobalt, it's 69% of global cobalt that comes from Congo. And we do have refining capacities in Finland, but not actually the capacity to gain the cobalt in the first place. So we're importing it and refining it. For others, it's the other way around. For lithium, we actually have own deposits in Portugal, but we don't have the refining capacities, which makes us again fully dependent on imports, particularly from China, from Chile. And then other examples like rare earth, they're quite a lot in the media. And for those of you who haven't read much about them, they're not rare and they're not earth, actually, they're metals. And there's a group of 17 metals that are super important for all high-tech stuff, mostly used in permanent magnets, which in turn are needed for all kinds of devices, like electronic cars or even normal car, even traditional ICE cars, wind turbines, phones, laptops. And they're actually quite widely available on the Earth crust, but they occur in such low concentration that it's just very hard to separate and it costs a lot of money. That's why the supply chain is almost entirely controlled by one country, by China. In the EU, the EU's import of permanent magnets is 98% just China. One also interesting one is magnesium, where the EU is also 100% dependent. And that's also super important for automotive industry, also packaging and construction. So if we take a look at the geographical inputs, of course, the supply chains are quite complex. So it's quite rare that it's just from one country and then imported to Austria. But there's mostly a long path of where it's mined, it's extracted, where it's processed, refined, further developed. So here we highlighted the country where it's most critical, where it's where the risk is the highest. And we can see that there's a very clear picture that China is just the one controlling the most, almost half of the materials. And this is particularly for Austria, but the picture is very similar to the EU. So the question is, what do we do about these dependencies? And by the way, so far, for a lot of them, these critical raw materials are very cheap to import. That's why we do it. But it can get very dangerous because imports can stop at any time. And China has already demonstrated that they are actually using that as a leverage point politically or economically. And Katharina will get into that later. But that's why it's super important to do something about them. So far, there are mostly three approaches from the Critical Raw Materials Act by the EU, which is building up own capacities, recycling, and diversifying. And while those strategies are important, they are structurally limited. Building up own capacities takes a lot of time and is very tricky because of the social and environmental aspects. That's why getting an okay to start something takes a long time. And for recycling, most of these have actually very low recycling rates. So 9 out of the 17 are barely recycled. It's like close to zero, the rate. And only very few have a significant amount because it's technically very hard and very expensive. And then there's a second aspect to recycling and own capacities that's tricky, which is the dependencies. They're not only on the raw material level, but they're actually on the level after the materials, the products that are being made out of the critical raw materials. And this further processing, that's also often very concentrated. So, for example, we might be able to get lithium ourselves or cobalt, but then we still need to make a battery out of it. And the cell production, again, very highly concentrated in China. Also the permanent magnet production. So if we recycle and then we get the black mass, mostly what happens right now is that this recycled metal is again exported to China or to other countries because they're the only one who can process it. And then diversifying is also generally an important approach, but also limited, as not all processes can be diversified, as sometimes there's only one country who has the expertise. So we try to look beyond these three approaches and open it more up. And we looked at a wider range of 10 and evaluated them on their efficacy for short-term and medium-term, how effective they can be in reducing our supply risk. And on this big picture, we can already see that the demand reduction side has the highest potential and has also simultaneously the lowest attention. So looking at these 4 measures, one is reduced demand for end products, and that's it's often not thought about, but that's very much connects to critical raw materials, that if we use more public transport, we won't need as many electric cars. If we use car sharing, ride pooling, and so on. But also for energy use, obviously we want to transition from fossil fuels to renewable energies, but we also might not want to increase our energy consumption as much and then not need as many critical raw materials. So energy efficiency measures. Like, again, we come back to renovation in buildings. All these play into our critical raw materials dependencies. But then there are also other measures that companies can do themselves, like improving material efficiencies, lightweight design and miniaturization. A lot of companies are already doing it because it can be cheaper. And there are also key policy levers, like a weight-based vehicle tax or eco-design standards on that. Then there is substituting critical raw materials. There we have no circularity sign because it very much depends on what you substitute with. If you substitute a cobalt battery with a nickel battery, it might be somewhat more reliable for now, but it's not. It's more circular, and that could also get rare. So ideally, you substitute with more circular or renewable alternatives. Then we have extend product life. I mean, circular design is by many scholars pointed out as actually the most efficient or the most effective measure, where you start at the very beginning of the supply chain and look there how you can make a product that it's durable, that is recyclable, and so on. And I think I just caught a glimpse at the question how we categorize them. And that was actually qualitative assessment. So we did literature research and then expert interviews. So that's not a quantitative estimate, but it's qualitative from different sources. And of course, the estimate differs a lot depending on what critical raw material or product we're looking at. So this is really more of a rough idea than an exact estimate. Or we just wanted to show how the difference is between the different measures. And then for reuse and domestic production, there's also a huge potential in reuse of products. For example, for batteries, an electric car at the end of their life usually has around 80% capacity still. And then that battery could be used in as stationary batteries. Okay, I'm going to go a bit quicker through the others because we're already quite advanced with time. But yeah, I've already mentioned recovering through recycling and then also building up own production capacities, which remain important specifically in the longer term, but in the short term, they're mostly limited. And then secure procurement measures like diversifying a long-term supply contracts and strategic reserves. We also need them, but they won't really change anything about our structural position. So if we look at the whole picture, it's clear that those traditional measures that we're looking at are just not sufficient, and we need to widen the scope. So now I want to bring all the studies together and kind of talk briefly about what conclusions we drew for policy measures. There is the Circular Economy Act coming up. There's supposed to be a Commission proposal by September 2026. We also talked to the Commission. A few weeks ago, they said they're not sure if they can actually make September. We'll see, maybe in November. And this one, again, is supposed to focus on recycling and on the secondary raw materials market, which is super important. As mentioned, there's a lot of potential there. And we do have a lot of recycling targets that are actually not met so far, so it's important to have that. But this focus is also too narrow, and we need demand-side measures. They need to become central to circular economy policy. We have the eco-design regulation in the EU, which is starting to do that, putting in standards for products that they are durable, recyclable, and so on. But the actual standards to take a very long time to materialize and to actually be built up. So far we only have a framework, and we don't have any concrete measures yet. Yeah, so for material consumption and for critical raw materials, the demand is just growing so fast that if we only go with recycling, there's just no way we'll catch up, because we just don't have enough end-of-life material to recycle it. So key levers would be ones that actually reduce material consumption. That can be building renovation again, public transport, energy efficiency, and so on. And then the second kind of main takeaway is that for reuse and recycling, we need to make it systemic and scalable. So there are recycling targets, like in the Critical Raw Materials Act, it's 25%, but they're nowhere near being met. And there isn't kind of systems in place that really make this work. Also for reuse, I mean, there are not even proper targets, but there needs to be systems like disassembly standards, material registries, batteries. There needs to be transparent health data that if you come at the end of life of an electric vehicle, you need to know kind of how much capacity is there left, and also is it safe? Otherwise, you don't want to put a battery in your home where you don't have all the information. And it's there. There is a battery management system, but the car manufacturers have just no interest in disclosing it because they have no interest in having it reused. So there just needs to be the policy framework to enable the systemic use. And part of it is also the minimum recycled content quotas. And they need to extend beyond plastic. We have ambitious quotas now for the plastic sector from the EU, but there needs to go beyond to other sectors and cover not only public procurement, which is important, but also then private markets, and incentivize really high value material cycles. So not only lower greater use, like as a road sub base, but that you actually can close the loop and have a high quality cycle. So yeah, in the end, we need to make sure that secondary raw materials are competitive with virgin materials at scale. And for that, we need the policies. So that was a quick run through. Now I'm going to hand over to Katharina. And there is so much more I could have said, but I don't want to make it too long. So I would love to dive into some bits that you guys are interested afterwards, if you have time. And now on to you, Katharina.
Thank you very much. And I'm really looking forward to your questions. So I'll make it very short. But let me zoom out for a moment. Because what we've just heard isn't only about sustainability. Of course, we need to use less. And we know that from an ecological point of view, this is just not discussed. This is no discussion. But this is also about power. Because over the past decade, China has systematically built leverage on the materials the world's economy depends on. Critical minerals for our cars, our chips, our energy systems, everything that we depend on. And China now dominates 70 to 80% of those critical raw material markets. And it hasn't stopped there. It has extended the dominance into processed products, as Jo mentioned. Batteries, solar panels, steel, the very building blocks of our ecological transition. And this is not accidental. It is strategy. And the EU is exposed. As we heard, almost 100 billion euros of Austrian exports alone depend on products that rely on critical raw materials. Multiply that across 27 member states, and you see the scale of the vulnerability. Now add tariffs, add export restrictions. The OECD has documented 5-fold increase in export controls on critical raw materials since 2009. When a supplier decides to restrict exports, as China has done with gallium and germanium, we don't just face higher prices, we face paralysis. So the question is, what do we do about it? And the answer is not just diversifying suppliers, as Johanna mentioned. It helps, but it doesn't fix the root causes. The answer is to use and reuse what we already have, to close the loop. So circular economy is industrial sovereignty. It is the only strategy that fundamentally reduces exposure, not by creating new dependencies, but by building independence. And our studies show that this isn't just wishful thinking, it is achievable. It creates jobs and value added. It fuels innovation, it lowers import bills, and it creates the strategic autonomy that no trade deal can give you. But this requires political will. It requires demand-side measures, not just recycling targets. It requires design standards, reuse infrastructure, secondary material markets, and it requires also that circularity is not only embedded in environmental law, but in industrial policies, in trade agreements, in security frameworks. And all this will not happen accidentally. It needs strategic thinking. The studies that we've presented today, they show part of the path, but it requires policymakers and all member states to really walk it. And this is also up to us. We as a strategic think tank, but also you and your organizations, to really leverage your power in your member state, but also on EU level, to bring those positions in, to really make circularity the heart of industrial policy of the future. And with that, I'll end, and I'm really looking forward to your questions.